Hello mathematicians, welcome back to my YouTube channel. Today lesson 2 of polynomials. The previous one we discussed some general properties about polynomial. Right now I want to discuss with you something very interesting. So I would like to tell you about roots of a polynomial. So let's write roots of a polynomial. What that means for exact. So if you consider it a polynomial from complex, and I will take a complex number alpha. If p of alpha is 0, that means that alpha represents a root of a polynomial p. And how we use this, and I like to tell you some examples of polynomial and special roots. So what that means in our economy of a polynomial. So we have that px is something like x minus alpha times q of x. So we can divide exactly the polynomial p at the polynomial of degree 1 x minus alpha. So q of x is from cx. And also degree of q is degree of p minus 1. But how many roots exactly have a polynomial? So it's very important rule and theorem which is dated to Gauss, which said that if you have, so let's tell the name of this theorem. So it's called the Fundamental Theorem of Algebra. So Fundamental Theorem of Algebra, which said that if you have a polynomial p of x of degree 9 n, p of x has exactly n complex roots. So for instance, p of x has the roots alpha 1, alpha 2, alpha n. Remember, you don't have that these roots are distinct. So we can have equality here. We don't necessarily have all roots distinct. If you like to write distinct, you can say that you have the roots lambda 1, lambda 2, lambda m, r, let's say r, and you have some multiplicity. So you have m1, m2, so it appears so many times. So you can write here p of x is like the dominant coefficient, because here look, it's very important factorization. So p of x can be written like an, the leading coefficient, times x minus alpha 1, x minus alpha 2, x minus alpha n, which can be written like an times x minus lambda 1 m1 times x minus lambda 2 m2 times x minus lambda r mr. Good. So we have this in mind. We have the roots. We have that some roots can repeat. Let's put some example. So let's start with, I will consider it good polynomials, and when I say good, I mean that have a less degree. So first example, let's say you consider it p of x like x squared minus 3x plus 2. So Here is a quadratic equation, and you can find easily their roots. You have x1 is equal with 1 and x2 is equal with 2. And when you put p of x, you just have 1 times x minus 1 times x minus 2. But how we handle if you increase the degree? So if not the easiest task, so let's write something like x cubed minus 3x plus 2. Here is not such an easy question, but if you look carefully, you will see that p1 is 0. And that's exactly what we want, because look, when you see at the beginning what I tell you that if alpha is a polynomial, alpha is a root, then p of x can be written like x minus alpha times q of x. So if you see this, you can write p of x like x minus 1 times, let's say, q of x. But how we handle to find it q of x? So the main idea is that you can write this expression like x cubed minus x minus 2x plus 2, which is going to be x times x squared minus 1 minus 2 times x minus 1, which can be written like x minus 1 times x plus 1 minus 2. And here is very interesting fact that you reduce this equation at, you see here is a quadratic, and you can find easily the factorization. So it's going to be x minus 1 times x plus 2. So you see a harder example, but I identify a very beautiful thing, that you have a root with a multiplicity. So here we have this polynomial. Good. So today's lessons was to find out what is a root and some specific example. Hope that you like it. Please like, share, subscribe. See you.